This video is on polarization. Question 1. Define unpolarized light. Electromagnetic waves leave a source, like a light bulb, the sun, or any star, with electric fields and magnetic fields, leaving and oscillating in all directions. The electric fields and magnetic fields vibrate perpendicular to each other. So this is what an electromagnetic wave looks like. This is happening in all directions. Okay? So, usually only electric fields are drawn, since accurately drawing unpolarized light can get very complicated. So unpolarized light looks something like this when you draw it, because this is a lot less realistic to draw on a test. Question 2. Define polarized light. Polarized light is unpolarized light which travels through a polarizer. The intensity of the light decreases by half after it travels through the polarizer. So intensity after equals 1/2 intensity before. After the unpolarized light travels through the polarizer, the electromagnetic wave's direction of oscillation is restricted. Only transverse waves like electromagnetic waves can be polarized. Longitudinal waves like sound cannot be polarized. So polarized light can be easily and quickly drawn like a line. Question 3. Define Malus's law. If we have two polarizers, then the outgoing intensity of the wave is given by the equation I out equals I in cosine squared theta, where theta is the angle between the two polarizers. So you can see we have unpolarized light coming in to the right. It goes through a polarizer, then it goes through an analyzer. So remember, unpolarized light, polarizer, analyzer. Question 4. What is a polarizer? Polarizers are devices that allow electromagnetic radiation to transfer through only in one direction. Question 5. What is the relationship between the incoming intensity of light and the outgoing intensity of light after the light goes through a polarizer? Okay, this is the equation. I out equals I equals 1/2 I in. Or I1 equals 1/2 times I sub 0, or I naught. Question 6. There are two polarizers. The first polarizer is vertically polarized. The second polarizer is placed behind the first polarizer and is shifted 30 degrees from the first polarizer. Draw a figure of the setup and find the intensity of the light after it goes through both polarizers. So, let's let I sub 0 equal 1, has a magnitude of 1. Then I1 is equal to 1/2 I sub 0. So I1 is 1/2. I sub 2 is I1 cosine squared theta. So I1 is 1/2, it's going to be the cosine squared of 30 degrees. So that means we only get 37.5% of the outgoing light. Okay. So you don't need to go into physics of polarizers into too much detail, but you do need to know how to apply Malus's law and how to interpret the intensity versus degree graph. Question 7. What would be the outgoing intensity if two polarizers are placed next to each other and are shifted 90 degrees from each other? Okay. Well, we know that cosine of 90 is 0, so cosine squared of 90 is 0. So we're going to get no light going out. So I sub 0, you're going to get light. I1, you get light. I2, you get no electromagnetic waves. Question 8. There are three polarizers. The first polarizer is vertically polarized. The second polarizer is placed behind the first polarizer and is shifted 45 degrees from the first polarizer. Finally, the third polarizer is placed behind the second polarizer and is shifted 45 degrees from the second polarizer. Draw a figure of the setup and find the intensity of the light after it goes through all three polarizers. Show all your work. So it looks something like this. So we got an equation for a solution for I1. We got a solution for I2. Finally, we got a solution for I3. Just show your work one step at a time. Don't skip steps because you might get the wrong answer at the end. Question 9. An unpolarized light passes through two polarizer sheets. If the intensity of the transmitted light is 20% that of the original light, what is the angle between the transmission axis of the two polarizer sheets? So here they're giving us the solution is 0.2 or 1/5. So we know I1 is going to be 1/2. And we know I2 is going to be 0.2 or 1/5. So let's solve for theta.